My name is Ernst. I'm an intern at Amazon and a PhD student at Dagan University. I would like to present our paper, re-examining summarization evaluation across multiple quantitative criteria. In this paper, we would like to question the way we evaluate automatic metric for summarization. So let's go deeply into the poster. So the conventional way to evaluate metrics is you take a set of summarization, you annotate the summaries using human annotations, maybe across different criteria, coherence, consistency, fluency, and relevance. And then you take metrics, automatic metrics, you measure the summaries using the metrics, and you calculate the correlation between the metrics scores and the human annotations. A metric that has the highest correlation is the best metric in this criterion. For instance, Meteor is the best metric in terms of fluency. It gets the highest correlation. Meteor uses lexical match, unigram lexical match between the system summary and the reference summary. In fact, it's a bit strange that this is the best metric in fluency because you can shuffle all the unigrams and get the same Meteor, but very bad fluency. So it's a bit strange. In fact, we conducted several corruptions in summaries, and most of metrics just ignore the corruption, meaning the score of the metric after the corruption was almost the same as before. For instance, we for each verb, we convert the verbs into their lemma form. Instead of has restarted, have restart. Instead of was brought, be bring. And Meteor and other metrics just ignore it. And we made other corruptions as well. But why does it happen? And we found that the reason is because there is high correlation between different criteria in human ratings. For instance, we have high correlations between Meteor, for instance, and relevance, meaning that if we have high Meteor, it means that the content of the summary is aligned with the content of the reference summary. This makes sense, as Meteor was designed to measure relevance. We have here high correlation. But we have also high correlation between relevance and fluency. This means that a summary that has high relevance also has high fluency. In other words, good summaries tend to be good in all criteria, and bad summaries tend to be bad in all criteria. This makes sense. So if we have correlation between Meteor and relevance, and we have also high correlation between relevance and fluency, we also get high correlation between fluency and Meteor. But this does not say that Meteor measures fluency. It just means that in this dataset, relevance and fluency are correlated. So this correlation is spurious. We cannot count on this correlation. We need to ignore this correlation. But how can we know which correlations we should ignore? After now we know that we need to ignore some high correlations. How can we detect these spurious correlations? We can use data bucketing. Let's say in our example that there is high correlation between Meteor and fluency. We have here data instances, and the curve, we have high slope, meaning high correlation between Meteor and fluency. But let's divide the data into buckets. Each bucket contains uniform relevance score. For instance, this bucket, this part of the data instances, contains only instances with relevance score of 1. This with only relevance scores of 2. So the relevance score in each bucket is uniform, is constant, but the fluency scores has high variance, meaning that the correlation between relevance and fluency inside each bucket is pretty low because the relevance is constant and the fluency is not constant. So we reduced the correlation between relevance and fluency. We reduced this correlation. So now we see that the correlation between Meteor and fluency inside each bucket is pretty low as well. We have this curve with low slope with respect to the original slope. So here we can see the more realistic correlation between BTO and fluency. In fact, we did it to many metrics, and we saw that in all metrics, that we saw that when we ignore relevance, when the relevance is the anchor, the difference between the bucketing correlation to the original correlation is pretty high, meaning we need to ignore, we cannot count on the correlation between metrics and coherence, consistency, and fluency. But when we ignore coherence, the relevance correlation is still the same. The difference is pretty low, so we can use the relevance correlation. So to sum up, we saw that before ranking metrics, we need to detect spurious correlations, and we can do it using data bucketing. Thank you for listening.